Before we get into the recommendations, when we say a 625 rated or 2250 rated barrier, what exactly do those numbers mean?
Those numbers refer to irradiance levels used in barrier testing, expressed in watts per square centimeter. For the barriers we're discussing here, the ratings are based on testing at 1064 nanometers using a 1 millimeter beam for 100 seconds.
So a 625 rated barrier doesn't mean it's designed for a 625 watt laser.
Exactly. The rating describes a specific test condition, not the power of the laser system. That's an important distinction.
And ratings like 575, 625, 2250, or 4000 watts per square centimeter aren't universal requirements tied to particular laser powers.
Correct. They're useful data points and can inform practical starting recommendations, but the appropriate barrier still depends on the actual application and expected exposure at the barrier.
Okay, real world scenario. I just bought a 2 kilowatt fiber laser for a small welding cell. What laser safety barrier should I actually be putting around it?
That's a very common question, and the answer is it depends. Laser power is a useful starting point, but it does not, by itself, determine the barrier rating you need.
Okay, so help me understand why. If I know my laser is 2 kilowatts, why can't I just look up the rating for 2 kilowatts and call it a day?
Because a barrier has to contain laser energy that reaches it, and how much energy actually reaches the barrier depends on a bunch of things beyond the raw wattage of the source.
Like what?
Wavelength, beam size, working distance from the interaction point to the barrier, the expected exposure conditions, the geometry of the cell, and the results of the actual laser hazard evaluation. All of those factor in.
So two facilities with the exact same 2 kilowatt laser could legitimately end up with different barrier solutions?
Absolutely. That is one of the key points in the practical guidance out there. Two installations using the same laser power may require different barrier solutions because their layouts, their working distances, their beam geometry, and the expected irradiance at the barrier can all be different.
All right, but I'm an operator. I still need somewhere to start. What does the practical rule of thumb actually say?
Right, so most people want a practical starting point, and there is a reasonable framework for common 1060 to 1080 nanometer fiber laser applications. The key word there is starting point. These are not universal requirements.
Got it. Starting points, not absolute rules.
Exactly. For example, for fiber lasers up to about 2 kilowatts, a common practical starting point is a 575 watt per square centimeter softwall barrier.
And what kinds of applications does that typically cover?
Handheld laser welding, smaller robotic welding cells, and general industrial laser containment. For many industrial welding applications, a 575 softwall serves as the standard starting point. Now, once you move into roughly the 2 to 6 kilowatt range, the practical starting point commonly shifts to a 625 watt per square centimeter softwall.
So why does 625 become the practical starting point in that range?
As you move into these higher power industrial applications, 625 provides an additional layer of material redundancy. Applications like laser cleaning can also involve reflection conditions that need to be considered in the hazard evaluation. Again, it's a practical starting point. The actual exposure conditions still determine what's appropriate.
Okay, what if my hazard evaluation tells me I need more headroom than that, but I still want something flexible?
Then you might look at a 2250 watt per square centimeter softwall. That gives you a substantially higher tested irradiance rating while staying with the softwall, so you keep that flexibility and portability.
Is that available in standard sizes?
The standard in-stock configuration for that material is a 5-foot by 7-foot panel, and it has been tested at 1064 nanometers using a 1 millimeter beam for 100 seconds.
So when would I pick that over a 625?
When your hazard evaluation indicates that a higher irradiance capability is appropriate, but you still prefer a flexible portable softwall barrier over a rigid hardwall system.
And what about hardwall? When does that come into play?
A 4,000 watt per square centimeter hardwall is an option when the hazard evaluation indicates a higher irradiance capability is appropriate, or when the facility prefers a more robust, rigid containment system.
What does hardwall actually give me that softwall doesn't?
It is a rigid containment solution, but it is still portable and modular, so you get a higher tested irradiance capability without having to construct a permanent laser enclosure. That makes it well suited to facilities that need that extra robustness but don't want to commit to permanent construction.
Can you walk me through a concrete example of how two facilities with the same laser power might end up with different barrier requirements?
Sure. Take a 4 kilowatt fiber laser. Facility A uses it inside a well-controlled automated cell. The process geometry is fixed, the beam path is predictable, and a protective barrier is positioned based on the expected exposure at the barrier plane. Their hazard evaluation may show that a lower-rated barrier is appropriate.
And Facility B?
Facility B uses the same 4 kilowatt laser in a more open application, where the working distance, beam direction, or possible reflections are less constrained. If the expected irradiance at the barrier is higher, their hazard evaluation could point to a higher-rated softwall or hardwall solution.
Same laser power, potentially a completely different barrier requirement.
Exactly. That's why laser power is useful as a practical starting point, but it doesn't replace evaluating the actual application.
I want to make sure I'm not mishearing this. These ratings, 575, 625, 2250, 4000, they're not universal requirements.
Correct. They are practical starting points for common 1060 to 1080 nanometer industrial fiber laser applications based on experience supplying barriers for those applications. They're intended to help with preliminary planning.
So, what assumptions are behind these practical starting points?
They assume typical industrial fiber laser use where the barrier is intended to contain expected laser radiation during normal operation. They are not a statement that the barrier can indefinitely withstand continuous intentional exposure to the direct beam.
So, at the end of the day, who actually makes a call?
Final barrier selection is the responsibility of the employer, the laser safety officer, or another qualified individual responsible for the laser safety program.
And that decision is supposed to be based on what?
On the specific laser wavelength, the beam characteristics, the expected irradiance at the barrier, the exposure duration, the system geometry, and the applicable laser safety standards, not just the kilowatts on the spec sheet.
And if I skip that hazard evaluation step?
Then you're substituting a general guideline for an application-specific evaluation, and that's not what this guidance is intended for. The practical rule of thumb is a planning reference. It isn't a substitute for the application's laser hazard evaluation and appropriate engineering analysis.
All right, let me try to pull this together. If I'm an operator with a fiber laser in the 1060 to 1080 range, what's my shortlist?
1. Know your laser power because it gives you a useful practical starting point. Up to 2 kilowatts commonly starts at a 575 soft wall. 2 to 6 kilowatts commonly starts at a 625 soft wall. 2, if your hazard evaluation indicates higher irradiance but you want flexibility, the 2250 soft wall is an option in a standard 5x7 configuration. If you want a more rigid, modular containment solution at higher irradiance, look at the 4000 hardwall. 3. Don't lock in a rating based on power alone. Working distance, beam geometry, application, and expected exposure conditions all matter, and two facilities with the same laser can legitimately need different barriers. And 4. The practical recommendations are starting points, not substitutes for a hazard evaluation. Final selection is the responsibility of your LSO, your employer, or another qualified individual responsible for the laser safety program.
That's a really useful framework. Anything you want to leave the listeners with?
Just this. If your application has specific questions, talk to your laser safety officer or another qualified laser safety professional. The barrier rating table is a starting line, not a finish line.
Great. This episode is based on technical guidance developed by Laser Safety Industries on selecting barriers for 1060 to 1080 nanometer fiber lasers. If you have application-specific questions, please consult your LSO or another qualified laser safety professional.
And this episode was created with the assistance of AI from technical content developed and reviewed by Laser Safety Industries.
Thanks for listening. We'll see you next time.